Hi all. Today I am going to explain about machine learning course assignment 6. In that important question, that is output value of neuron in this given picture. It's an artificial neural network sum where we have nearly 3 sums forwarded to each other, and here is the first sum, and then the first question we can say that as what is the output value y from neuron 6. So here we have 6 neurons totally. In that, what is the output value of the 6th neuron they are asking about. So what is the y value of the 6th neuron? That is what we are going to find in the first question. So first we are taking about the neuron 1. So here we can say that we are going to calculate the neuron 1. Neuron 1 has 2 inputs. From x1 we have 1 input and x2 we have 2 inputs. So the neuron 1 has 2 inputs with a weightage of 0.2 with a weightage of 0.2. So the neuron 1, it has 2 inputs, x1 and x2, with a weightage of x1 and the weightage of x2. So what is our x1 value? x1 value is 1, and then the weightage in the x1 value, that is 0.2. Our x2 value is 2, and then the weightage of that x2, the lines from here to there, we can clearly see that from x2 to neuron 1 the value is 0.2. so if we are multiplying that one, we will get our value at which means our output of our neuron 1 is 0.6. We have to do the same for all the neurons in the first stage. So what is our second neuron? This is our second neuron. Even it is also having the same inputs. It has 2 inputs from x1 and x2, and then with the weightage of same value 0.2, 0.2. So once if we do that evaluation, so here for the neuron output of y2, what we will get 1 into, that is our input value, 1 into, that is our x1, 1 into 0.2 the weightage, and then 2 into, that is our x2 value, 2 into the weightage 0.2. So we will get the same values for x1, x2 and x3, which means our neuron 1, neuron 2 and neuron 3 all are getting the same values of output, because for everything the inputs and the weightages are equal. That's why we are getting all this 1, 2, 3 neurons. The outputs are equal, same values we are getting. Then we are going for the neuron 4, which is in the second stage. Okay, so in neuron 4, what we need to do is input value and then with the weightage. So what is our input value for the neuron 4? One input is from neuron 1. So what is the neuron 1 output? Is the input for the fourth neuron. Okay, so neuron 1 is neuron 1, that is our y1 value into the weightage. So what is our neuron 1 y1 value? Y1 value is 0.6. So 0.6 into the weightage is 0.2. Again for here what we get, neuron 2 output value. Neuron 2 output value is, that is y2, 0.06 into the weightage is nothing but 0.2. Again, what is the third input for the neuron 4 is from the third neuron. Okay, from the third neuron, what is our value? Third neuron, so here you can see 0.06, and then the weightage of that line is 0.02. Once if we multiply and add up these all, we will get 0.36. So this is our neuron 4 output value. So we can consider that as a y4 output value. The same lines and same weightages for neuron 5 also. So once if we calculate that one, we will get 0.03, the same value what we got for neuron 4, the same value we will get for neuron 5. Now we are going for neuron 6, because they have asked us to find only the output value of neuron 6. So we are starting from neuron 1 to the neuron 6 we are going. So now what is our neuron 6 value? We are getting 2 inputs, one input from 4 and another one input from 5, neuron 4 and neuron 5. Already we found the neuron 4 value, that is nothing but 0.36, and then for neuron 5 output value also 0.06, and then what is our weightage? 0.02. So once if we multiply and add up neuron 4 and neuron 5, we will get our overall output of our sixth neuron. So here our output value of our 6th neuron they are asked to find. So this is our output value of our 6th neuron. So when we are going for that, our answer is correct. 0.14 is our answer. So which is being correct over here. Okay, and then this is the second question, which followed with the same data of the first question. Here they have asked us to find the propagated error sensitivity at neuron 1. It is very important, we have to consider as which neuron they are asked. Either they asked neuron 1 or neuron 4 or neuron 2 or 3 or 5, because according to the neuron value that back propagation varies. So here they have asked to find the error sensitivity as well as the back propagation. The error sensitivity we have to find it through the back propagation. Okay, so at the neuron 1, back propagation means we shouldn't go from front x1 to 6. We have to come from 6th to first. Okay, 6th neuron to first neuron. So how to come from before going further, we have to find the error sensitivity. The error sensitivity, even in the question itself they have given the formula for error sensitivity of an output is target minus output value. So just in the previous sum we found the output value of our 6th neuron, that is nothing but our 0.144 minus our target value. Target value is already given in the question, that is 0.344. so once if you minus, we will get the back error sensitivity value of our neuron 6. Once if we got that error sensitivity, we have to back propagate to the neuron 1. Okay, so what is our neuron 1? Here they have clearly mentioned for how to back propagate. Also here they have clearly mentioned our formula, that is weightage into dj, which means the data we got it, okay, that error sensitivity data we got it. Okay, this value. So what's our weight? So here if we are back propagating from 6 to 4, what is our weight? Our weight is 0.02 dj, and then our weight is 0.2. So if we multiply that one at 4th neuron, we will get our value as 0.04. Now we want to go back to our first neuron. So again the same value, what we need to do is here for 4th neuron only one input from 6th, but in the first neuron there are two outgoings are there. One is from the 5th neuron as well as another one is from 4th neuron. So we have to calculate both the weightages of the 4th neuron, and then we found this dj at 0.4, that value. Again the same we have to do it for the 5th neuron also, because that our neuron 1, it has two outgoing things. So the weightage, what is our weightage? We know that 0.02 is our weightage, and then what is our di at 5? That is our output, which we found a weightage into our dj. So that value we will get most probably for 4th and 5th are same. 4th and 5th neurons are same, that's why we are getting the same value. Once if you multiply, we will get 0.0008 plus 0.008. Once if we get the adding those both, we will get our back propagated error sensitivity at a neuron 1 value, that is nothing but 0.016. okay, it is very clear. And then in the same question they are going for, with the same data they are asking the third question also, which carries 2 points. And that, what is that one means? Updated weight for connection between our input x1 and neuron 1. See here, it is very important to notify that one, what the question they have asked me from the input x1 and the neuron 1. This is the third question from the same database, and we have to find from the previous question. If you find that previous question answer only, we can answer this question also. Okay, so what we found is that in the previous question our di at 1, see di at 1 is nothing but 0.016. okay, with that value we have to multiply our x value. Okay, what is our x value? That is 1. If we multiply our x value plus the weight, what is our weight here? That is 0.02. Why we are taking only x? Because in that question itself they mentioned they need only x1 to the neuron 1. They don't want x2, so we are taking only x1. The x1 value is 1 into our previous output, that is back propagated error value. We are taking that into within weight. So once if we add that, when we will get our answer as 0.216. okay, so remember that these 3 questions follows one on another. Once output will be given to another question's input, and then once again that question output is given to the next question's input. So with that we can very clearly, very easily get all these 5 marks based on this question. Okay, thank you for listening. I'll meet you in the next question. Thank you.